Okay, if you open the ts.rmd file, you will see something like this. You will see this one, and then if you click the visual, then your document will be way better to see. So I want to open the console here so that I can see the number, but actually, yeah, you don't have to. So this is about the time series data using the R. So TS is the time series, shorten is a TS, time series. This is a data type in the R. So this is a equal spaced time series data, which means it's like every year. It's not jumping. So you have exactly 1 year difference the data, or the every month data. If that's equally spaced time series data, then you can use a TS. Actually, if you open this one, and then if you open the data, this one and this one is actually the time series. You cannot open it because this is not data frame, but it works exactly the same. The reason is this one is also exactly the evenly spaced, and then year 1000, I mean the 1948, 1949, 1940, 50, 51, 52, and so on. Okay, and then also this data file has the interest rate of the 3 months treasury bill, but to see the lagged the effect. So what if this current interest rate is affected by the last year's interest rate and last year's interest rate? So this is the one lagged data. So 1.04 is 1.04 move back to the previous, right? So when we do the 1948, 49 data, then you have a last year's interest rate, right? And inflation also is a one lagged, right? Everything is a one lagged. So you can find out if you want to run the regression, you don't have to create any lag, and you can simply use this lagged data, and then you can run the regression. So one lag. But this is gonna be a little tedious. How can I generate the lagged column? So we will use some other function so that we can do. So you can just change it to the TS, and then you can, after that you can do anything. But actually in our case, you don't have to change it to the TS data file, data format, because the INTDEF is already cleaned. So you can directly use INTDEF, but when the data is pretty messed up, it's not in order of the year, then you can change it to the time series data type, and you can specify the starting time. Okay, so you can run the regression. So in this case, we are not using the past data. However, you can still run the regression, and then you find what is the this is a more like a static regression model. And zoo is also the same as a time data type here, but again, as I told you, INTDF is already pretty clean the data frame, so actually changing to the TS or zoo doesn't do much things. But when your data format is pretty dirty, then this changing to the zoo or TS can be very useful. So zoo is the irregular, not only the equal space, sometimes it's not equal space, then you can use a zoo instead of TS. TS have to have exactly the same space, but zoo doesn't have to have. So you can change it to the INTDEF by years, and then you can change it to the zoo data type. Again, you can draw. Yeah, I have to. Yeah, I forgot. I have to install the package zoo because I didn't install here. So you have to open it, and then second time you learn it, then you don't have to have this one, right? So this is exactly the same. Again, our case actually you don't have to change it to the TS or zoo because our data set is pretty clear. And I'm introducing the DYNLM. So this is actually the dynamic linear model. So this is a same as a linear model, but it allows some fancy formula here. Fancy formula means is you can generate the leg. I don't have to create a new column with a leg. You can simply say Lx is the leg by 1 and Lxk is the leg by k time unit, and D is the difference if you want to use a difference. And then also the trend, you can use a trend and then seasonal. So yeah, I should install the again. I think this is okay, even though I don't have Alto, so actually this version doesn't have, but still, yeah, this worked. So maybe you don't have to install the Alto. It's required to build the R package, but it's not currently installed. Yeah, somehow it works. So yeah, so now I will just mark out. And we bring up to the library dynamic linear model and then car and linear model test. And then I bring the another data file. This is a fertility rate, right? And then PE, which is the tax exempt, and years, right? And T is the time 1, 2, 3, 4. Instead of year, it has like a 1, 2, 3, 4. And then this P underbar 1 is the the 1 year lag, and 2 is a 2 year lag, and 3 is a 3 year lag, and 4 is 4 year lag. However, so it's already generated, so you can simply use a P1, P2, P3. However, the creating this lagged data point is kind of tedious. So instead of do that, so we can just use here dynamic linear model, and then I can create the LPE, which means it's a 1 year lagged PE, and this is the 2 year. This is a 2 year the PE lag, and World War II or not, and then we have a pill or not. So there was the birth control pill or not. And then if you learn it, then you can see the regression model here. This is a model, and then you can find the coefficient. Since you can see the PE is like a P value is like a 56%. 1 year lag P is 97%. 2 year lag P is like 78%. It seems like a PE is they are not doesn't have any effect on the dependent variable. So we can use a linear hypothesis, and I wanna introduce this one. So actually this is a match coefficient function, means I wanna see the any independent variable here that contains P and E. So P, LP, LPE2 is the P related. So I want to see the linear hypothesis. So here the hypothesis will be the coefficient of PE is 0 and the LP coefficient of the LPE will be the 0, and also coefficient of LPE2 is 0. That's our null hypothesis. And then if you learn the null hypothesis here, this is a null hypothesis, P0, LP0, LP2 is 0, and we learn it, and then our p-value is a 0.01, which means this is not 0, right? We can reject our null hypothesis, which means PE has a clearly effect on the the dependent variable, right? So even though individually they are not significant at all, however, the P has a clearly effect on our independent variable. So this is the Durbine-Watson test. So I'm running the first one, output is like this, and second one output is like this. But basically this is the same thing. The statistics is 0.188, 0.188, and p-value is pretty small, and here is considered as a 0 because it's really small. So we can reject our null hypothesis. What was the null hypothesis? Null hypothesis rho equals 0, which is no autocorrelation, but we reject it, so which means there is a correlation. True correlation is greater than 0, so we can tell it's a positive because 0.1 is 0.18 is the more close to the 1, right? It's a positive autocorrelation.